More than a year ago, I was looking at the World Chess Championship. It was the one between Dinglerin and Jan Nepomniachtchi. Magnus wasn't playing, I wasn't that into it. Anyway, the commentators were talking about how great the Stockfish engine is, or something like that. I wasn't paying much attention. And as a programmer, of course I was like, I could do that. So I do what every programmer does, and I look up a chess crate on Crates.io, put together a simple minimax evaluation system, and would you look at that? It sucks. After the initial failure, I kind of gave up. I forgot about it. I moved on to other projects, and I could have left it there, should have left it there. But then, for some reason, I picked it up again. First thing I did was to get rid of the chess crate. I didn't really like the way it was set up. There were a couple things I thought were missing. It can generate SEN notation, it didn't generate boards out of move generation, which I thought was a waste. Overall, I just got fed up not being able to make adjustments to the game crate, so I thought, how hard could it be to make the game myself? You would think that since chess is such a simple game, it would be a simple task, but as it turns out, chess has a lot of rules. So I built my board representation and move generation in C, with a bit of help from the chess programming wiki. I actually ended up learning a lot about bitboard representation and how move generation can be optimized with some clever bit shifting. My reasoning was that I'll just write a wrapper in Rust over this bitboard logic, but that Rust layer just as soon turned into a second layer of hell when I realized I still needed to do the castling, the promotioning, and the en passanting. It was just a mess. For anyone inspired to write their own chess engine, learn from my mistake, just use a pre-existing library. You might think you want to code one yourself, but after a while, you'll wish you hadn't. And so I built a chess library, which by the way took me like 3 months because I only spent a couple of hours on it like once a month. I had other stuff to do, okay? And it also wasn't that much fun. Then I put together a simple alpha-beta pruning algorithm, added some multiprocessing, and would you look at that, it still sucks. Which isn't surprising. All I changed was the underlying game logic, and since the game was still the same, the engine performed no better than it did previously. Turns out the search algorithm is really slow and could probably use some optimization, but that sounds really difficult and sounds like a problem better handled by future me. So I procrastinated speeding up the search algorithm by implementing an opening book. I found a chess game database from which I could download like thousands of games. I then put all the moves into a big move tree that showed the most popular move in each position, and boom, opening book acquired. There's a little more to it than that, but that's the gist of it. Of course, that really didn't fix the main problem. The search algorithm was still super slow because I didn't bother fixing it until now. So very basically, the search algorithm is the main driver of the system, figuring out which moves are worth investigating and which ones are so utterly terrible that they can essentially be ignored. This is done by expanding a tree-like graph structure from the current position, generating moves from each board state and evaluating as we go until we reach the time limit. When the time is up, we can simply start from the top, applying a simple minimax algorithm to find which move we should play to reach the best outcome. First thing I decided to do was to redesign the evaluation function. My previous strategy of pulling numbers from thin air turned out to be insufficient, so I found a collection of constants that I could base my evaluation on. Slapped that together, and all of a sudden the engine seemed to be a huge fan of the Bon cloud, and apparently we're back to square one. Or, well, E2. Okay, finally got that working. Turned out the p-square table was plugged in the wrong way. Now, pop quiz time. What would you play in this position? Your knight on e5 is under attack, so you should probably move it, right? Not to worry, you have plenty of good squares to move it to. Knight d3 and knight c4 are perfectly reasonable moves. You want to know what's not a good move? Bishop b5 check. This is just so pathetically bad, and it turned my attention to the final boss of this project. I don't know if there's actually a term for it, I didn't do much research, but for the sake of this video I'm going to call it deep eval bailout. Let me explain. So here's the thing. The search algorithm is split into two phases. First, the engine won't care about evaluating the best move, just going from the topmost part of the tree and building a foundation from which phase 2 can work. It's like an onion, building layer after layer, and when the deep layers are rotten, it's difficult to tell what's wrong. Now, phase 2 is where the engine really kicks into action, finding and evaluating only the most promising moves, which allows for deeper search. It's like if the onion was sprouting new layers depending on where it thinks the best opportunity will be. Okay, this metaphor is kind of falling apart. Let's go back to that position from before. The reason bishop b5 is such a bad move is because black can play c6, now attacking our bishop and our knight at the same time, effectively guaranteeing that black will win material on the next move. Of course, white can delay this for one more move by capturing on c6 with check, forcing black to address the attack on the king. Because the first phase of evaluation only covers a very limited depth, this move should be covered by the second phase. But this particular move is actually never searched, and here is why. It's black's move, meaning that the engine is trying to find the move with the lowest score, finding the best move for black. This position, just looking at the material and how the pieces are placed, ignoring attacks from the black pawns, is actually pretty good for white. Look at the knight, well placed, covering squares around the black king, and the bishop is well placed, positionally anyway. The queen is active and white is overall ahead in development, and up one pawn. This means that, heuristically, this position will be evaluated at about 1.8. This means that the position will never be searched by the engine because it thinks the position is too good for white and can thus be cut off. This is where I realized that the positional evaluation and the search priority really cannot be the same score. Just think about it. If a piece is captured, that's a huge heuristic loss for the side about to move, which in turn means that the move is highly unlikely to be explored, which in practice means that the engine refuses to evaluate recaptures. To counteract this, I came up with a way of prioritizing moves based on some key characteristics. Instead of expanding promising moves based solely on their evaluation, each move is assigned a priority score, which is basically just a fancy way of giving artificial bonuses to moves that, even though they look bad at first glance, should be expanded. Like for instance captures. If a piece is captured, it's probably worth investigating to see if there's a potential trade or an epic piece sacrifice that could lead to a better position, and so I gave a big boost in priority for those moves, forcing the engine to expand captures. The most important thing here is that the priority score is just that, a priority score. When the engine actually chooses a move, it does so based on the heuristic evaluation. Completely new system implemented, and wow, it actually isn't terrible. It's actually really not bad. But wow, I was not expecting this. After a little tweaking and some bug fixing, I've decided not to continue work on this project. For now anyway, there's still a bunch of stuff I'd like to do, but I'd like to move on to other projects. For the question everyone's here for, how good is it? Well, to test that, I faced it off against some of Chess.com's bots in a chess bot playoff. Let's hear it for our first challenger, Wally. Nope, not that Wally. Apparently, my guy loves endgames and has some sort of fascination with the Loch Ness Monster. Wally has a rating of 1800, which is higher than my rating by quite a bit. So in this game, I'm no less of a spectator than the thousands of viewers on Title Tuesday watching games on Twitch going, "Ah, yes, it appears Hikaru is losing. The eval bar is plus 0.5 after all." So without further ado, my engine starts off with e4. Wally plays the Pirk defense? Pirk defense? Pirk defense? Which I'm not too familiar with, but it seems that the opening database is sufficiently sophisticated because my engine actually plays the main line. Or, well, I guess it's called the classical variation. Anyway, both sides castle and the game is roughly equal out of the opening. And then my engine strikes. You know what? The engine needs a name. I can't keep calling it my chess engine. It sounds like some coding tutorial, which it should be pretty clear at this point, it is not. Okay, so my brain is making some moves in the center of the board. Seems like we have an early queen trade, and yeah, I'm not going to be commentating on the entire game. You get it. It's a pretty balanced fight until Wally makes a blunder, And well, after that, it seems like Wally just kind of gives up on life. Brain is a pawn up, and my dude doesn't even bother to defend his rook. So yeah, so much for loving endgames, I guess. Anyway, at this point, it's pretty much smooth sailing. Brain converts convincingly, and the game eventually ends in checkmate with rook e8 on move 51. So with Wally conquered, everyone welcome Manuel to the big stage. This guy is apparently quite the romantic, which is a really strange way to describe a computer program. Unless... Moving on from that aggressively unromantic interaction and disregarding the fact that ChatGPT doesn't have eyes, you know, those things one might use to, look at me. Brain again decides to open the game with e4 as the one-trick pony he is. Like all true romantics, Prince Charming counters with the Sicilian defense. We get an open Sicilian, and because he's really just Alva Zero in disguise, dude plays h4 completely unprovoked. Now, here's actually a nice moment, because b5 is a bad move, and Brain immediately punishes the mistake, trapping the rook on a8 with the bishops on d5 and e3. And once the advantage has been given, Brain is just ruthless, forcing Loverboy over here to give up material, launching an attack, bringing all the white pieces into the attack, and eventually overrunning the black defenses. I'll tell you, I was really happy to see the way this game played out. But all good things must come to an end, and it turned out that Mr. Rigged Algorithm really wasn't that intelligent a network. I'm just gonna speed through a game against Sophia, rated 2300. Brain still played alright. Chess.com estimates its rating at about 2100. What I realized watching this game is that Brain tends to play the opening and the early middle game very well, but loses track towards the end game. I think it might have something to do with the search penalty I put in for really deep moves, which is great for the middle game, but might prevent Brain from searching certain lines in the end game where there aren't as many lines to explore. Anyway, I'm really happy with the way this project turned out. I'm thrilled that I was able to make an engine that actually plays chess better than me. Still, it's a project that's always going to be unfinished. I could always improve it just a little bit more, push that boulder just a little bit further. Really, the reason you shouldn't create a chess engine isn't because it's too difficult, but rather because it traps you in a loop of refactoring and improvements of a project, the final version of which you'll never get to see.